Okay, so what I want to go through in this video is how to do the wavelength concept builder. So you have the three trophies, and you're going through and you're completing each of these. So the first trophy, what you're doing is you are identifying different parts of a wave. So this first one, what it wants you to do is identify how many crests and troughs. So you just count how many crests, the top points of the wave here, and then you count how many troughs and you enter that in. So there's going to be a few different questions that go through different parts of a wave and want you to count or identify different parts of the wave, and that's that first trophy. The second trophy, what you're doing is you're counting the number of waves. So let's look at this one here. So you're counting how many waves there are in this wave pattern. Remember, one wave includes a crest and a trough. So one wave will look similar to this, okay? A wave pattern is all of those waves joined together. So if we look through here, the easiest way to do it is we're starting at this point right here. And I'll switch colors here so it's a little bit easier to see. We're starting at this point right here. And we have a crest and a trough. So that right there is one wave. We have a crest and a trough. There's a second wave, a crest and a trough. There's a third wave. 4, 5, 6. So remember, an up and a down, a crest and a trough counts for one wave. So in this example, we have 1, 2, 3, 4, 5, 6 waves. So we're going to enter in here 6 waves. Good. Let me clear my screen here before we move on. So the other thing I want to talk about, this one isn't an example of it, but remember, you can have half of a wave. So we have an up and a down here. That's one wave, and up and a down. There's 2 waves, and up and a down. There's 3 waves in this wave pattern here. If our wave continued on and only had an up, a crest, that would mean that this would be 3.5 waves. So half of a wave is only a crest or a trough, okay? In order to be a full wave, it has to have a crest and a trough on it. But if it has a half of a wave, it's either going to have one crest or one trough left behind after you've counted all the full waves, okay? So this one doesn't have that extra little half piece, but if you do see, when you're counting your waves, if you do see an extra half piece on there, or an extra piece of your wave, like an extra crest or an extra trough after you've counted the full waves, that counts for half a wave. Okay, so this whole trophy, you're going through and you're counting the number of waves there are. A wave looks like this. It has a crest and a trough in it. It has a crest and a trough in it. Okay, or it could go trough crest. It depends on what your wave starts on. Okay, let me clear my screen. We're going to go back to looking at how to do the third trophy then. For this third trophy, you're actually calculating the wavelength of the wave. Now, we talked about this in class, how you could calculate it if you knew the speed and the frequency of the wave. The second way you can calculate the wavelength is if you have the wave pattern and the length of your wave. So we're going to look at how to calculate the wavelength of one wave in our wave pattern. Okay, because remember, the wavelength is from one part to the next similar part on our wave. So one single wave we can measure the wavelength of, and that would be the wavelength of our wave. Like in the previous one, for this activity, the first step is to count the number of waves you have. So we have a crest and a trough there. There's 1, a crest and a trough. There's 2, and a crest and a trough. There's 3. So we have 1, 2, 3 full waves in this example. Okay, so our number of waves equals 3. To find the wavelength, then, what we're trying to find here, the wavelength, what you're going to do, and I'm going to abbreviate it. Remember, wavelength we can abbreviate with the lambda symbol. The wavelength is equal to the total length of our wave. So this is the total length of our wave. We're going to call that L. The total length of our wave divided by the number of waves we have. Divided by the number of waves we have. Okay, that is our total length divided by the number of waves we have is our wavelength. Okay, so for this example, we counted. We have 3 total waves. So we're going to take 4.8, which is our total length of our wave, divided by 3, which is the number of waves we have. We can do that on a calculator. And we should get 1.6 as our answer. And remember, wavelength is in meters. So our answer is 1.6 meters, but we don't have to include that because they have that written right there. Okay, check our answer here. We got it right. Let me clear my screen real quick. So yes, basically what you're doing to find the wavelength, remember wavelength equals the total length of our wave pattern, the total length of our wave pattern, which is given to us right there, divided by the number of waves, which we have to count. And remember, a wave is a crest and a trough. So this one has 1, 2, and then it has a half. So this one has 2.5 waves, 2.5 waves. Okay, so you're taking your total length divided by your number of waves to find your wavelength of one wave.